Section 5.6, Application Problems and Proportions. So there's one type of a proportion type problem that you'll see, and that is called work problems. They come from the work principle. Suppose that A is the time it takes A to do a job, and B is the time it takes B to do the same job, and T is the time it takes both of them to do the job together. Then T divided by A plus T divided by B equals 1. So we're going to take whatever they tell us, a job or a task or anything that takes one person and another person, we're going to write that number as denominator. And we're going to create that proportion. So let's do an example. And these work problems all kind of follow that same outline. We have Matt and Adam need to repaint their parents' house. Matt can do the job alone in 45 hours, and Adam can do the job alone in 60 hours. How long will it take two of them working together to paint the house? So we see that it takes one of them 45 hours and the other 60. So we go ahead and follow that outline from the work problems to fill this out. So we have T over 45 plus T over 60 equals 1. And there we have it. Now the trouble we have to do is find T, and T, our answer, will be Matt and Adam working together will take, and then you write your answer in hours. So let's go ahead and do the work for that. All right, so to do this, you have options. You can add your two fractions and then cross multiply, or do whatever you like to solve for T. What I like to do is multiply both sides by the LCM. So let's take the time to figure out what is our LCM between 45 and 60. Okay, so let's prime factorize 45 because I can't tell straight off the bat. So 45, we get it from 5 times 9. 5 is prime. We get 9 from 3 times 3. 3 is prime. So we get 45 from 5, 3, and 3. Let's take a look at 60. I get 60 from 6 times 10. I get 6 from 3 times 2. 3 and 2 are prime. I get 10 from 2 and 5. 2 and 5 are prime. So we get 60 from 3. That's right under the repeating 3. We have a 2 and another 2 and a 5. So let's write it under the 5. So let's multiply them to find our LCM. So we have 5 times 3 times 3 times 2 times 2. And that gives us 180. So let's go ahead and multiply both sides of our equation by 180. Let's distribute it to that first part. So we have 180 times T over 45 plus 180 times T over 60 equals 1 times 180. All right, so here 45 and 180 divide evenly. So we get 4. We have 14 plus 180 and 60 divide evenly. So we get 3T. And 1 times 180 is 180. 4T plus 3T is 7T equals 180. Lastly, we divide both sides by 7T. So we're left with T equals 180 over 7. So our answer is 180 over 7 hours. Or if we want to, we can write it as a mixed number, or 25 and 5 over 7. So that's our answer. Matt and Adam working together will take 25 and 5 over 7, or 5/7 of an hour. Problems involving proportions. A ratio of two quantities is their quotient. For example, 45% is a ratio of 45 to 100. A proportion is the equation stating what two ratios are equal. So ratio, proportion, that's just a different way of writing a fraction. Proportion. An equality of ratios A divided by B equals C divided by D is called a proportion. The numbers named in a true proportion are said to be proportional to each other. So let's do an example. So with these problems, try to set it up so that you have your story in a fraction. So whatever part to some corresponding whole and part to a whole. Now, the story can vary. Let's take a look at the example 2. A sample of 186 hard drives contained 4 defective drives. How many defective hard drives would you expect in a sample of 1,302? So our story here seems to be about hard drives and samples. So let's create a fraction about samples and hard drives. All right, now we have to kind of pair our numbers according to the story that it's telling us. So for example, the sample of 186 hard drives contained 4 defective drives. That's 1. How many defective hard drives do you expect in a sample of 1302? We don't know how many, right? So that's enough for us to create our proportion. So our sample is 186. Our defective hard drives are 4. Our sample is 1302. Our defective hard drives, we don't know. That's what we want to find. How many of them? And that is it. You have successfully set up a proportion. Now, to solve a fraction equal to a fraction, you just cross multiply. All right, so we have 186 times x and 4 times 1,302. All right, so we have 186x equals 4 times 1302. We get 5,208. Let's divide it by 186 to get x by itself. And x is made up of 5,208 divided by 186. So we're left with x is equal, if we punch that into a calculator, we get 28. So we have 28 defective hard drives. Let's take a look at example 3. To determine the number of humpback whales in the pod, a marine biologist, using tail markings, identifies 35 members of the pod. Several weeks later, 50 whales from the pod are randomly sighted. Of the cited 50, 18 are from the 35 originally identified. Estimate the number of whales in the pod. Okay, so again, we want to create a fraction based on our story. So we have whales identified divided by the pod. So our proportion can be made up from the 18 out of 50 equal to 35 by the ones we want to estimate. From here, just as before, we cross multiply so that we have 18 times W equals 15 times 35. All right, well, 50 times 35, that gives us 1750. That's equal to 18W. Let's divide by 18, divide by 18, so that we have W is equal to 1750 over 18, and if we punch that into a calculator, it's 97.22. So W is equal to 97.22. And last problem for this section. Jake's new scooter goes 4 miles per hour faster than Josh's does on his scooter. In the same time it takes Jake to travel 50 miles, Josh travels 48 miles. Find the speed of each scooter. All right, so we're talking about, let's put some stuff together. So we're talking about Jake, and we're talking about Josh. All right, so let's create a variable. Let's make Jake t. If Jake is t and Jake's scooter goes 54 miles per hour, Josh's scooter goes 48 miles, but how can we relate it in terms of our label, which is Jake? Jake is t. Well, we said that Jake's goes for faster. So Josh doesn't go for faster, it goes for slower. So t minus 4. Now we actually already set up our proportion. We have t over 54 equals t minus 4 over 48. Let's go ahead and cross multiply so that we have 48 times t equals 54 times t minus 4. Let's go ahead and distribute that 54 so that we have 48t equals 54t minus 216. All right, let's go ahead and get our t's together. So minus 54 minus 54t. We're left with 48 minus 54. We get negative 6. T is equal to negative 216. Divide by negative 6 to get t by itself. Negative 216 divided by 6, we get positive 36. All right, so Jake is our t, right? Jake is our t. Jake travels at 36 miles, and Josh is 4 miles less. 36 minus 4, Josh goes by 32 miles per hour. And that is the speed of each scooter. All right, that's it for section 5.6. Thank you.